Hello, welcome back to the channel. So let's do some definite integration problems. The problems in which we have to evaluate a given integral by interpreting it as a signed area and using geometry in this case. So in this question, we have to calculate the area under the curve for the function absolute value of t minus 1 between the intervals x equals minus 3 to x equals 5. So the same thing that we did in the last video as well. If you have not watched my previous video on the signed area calculation, I would highly suggest you to first watch that video. So we'll use the same basic approach in this question as well. We'll sketch the graph of the function, and since in this question we have to calculate the signed area, every area which will lie below the x-axis will consider it to be negative, and every area which is lying above the x-axis will consider it to be positive. Okay, so now let's sketch the graph of this function, and I'll show you a trick as well if you find some difficulty in sketching the graph of absolute value functions. So in this question, we have to sketch the graph of the absolute value of t minus 1. It can also be taken as the absolute value of x minus 1 for simplicity if you want to relate it to x and y axis, but both of these notations are the same because in this case, since my t is varying from minus 3 to minus 5, it doesn't make a difference if I take t or if I take x in this case. So I'll continue with t only in this question, but you can take x as well. The answer would not change. So let's sketch the graph of this function. I'll draw the axis now. So this is my y-axis. This is my x-axis. So whenever you have to sketch the graph of an absolute value function, I would first suggest you to draw the sketch of the function without the absolute value signs. So we'll start with first sketching the graph of y equals x minus 1 without the mod signs, without the absolute value signs. And we'll also see how this approach will make our graph sketching process much easier. So let's sketch the graph of y equals x minus 1. And I know that since my y equals x graph is like this, and now since I want a graph for y equals x minus 1, if I move this line 1 units down, because it's x minus 1, I'll get the graph of y equals x minus 1. So now I have got my graph of y equals x minus 1. Now my next plan is to find the graph of y equals mod x minus 1. And in order to do that, the process is very simple. So whatever part of the graph you have below the x-axis, so in this case, it's this part, and whatever part of the graph you have below the x-axis, just flip it with respect to the x-axis and move it above the x-axis. You have to just flip it by taking a mirror image with respect to the x-axis. So if I flip this graph, if I flip the negative portion of the graph above, I'll get this one, right? And now if I erase the unnecessary parts of my graph, my final graph would be this one, which is the graph of y equals absolute value of x minus 1, or in this case, it's t minus 1, where I have denoted this axis as t and this is my y-axis. So now since I've sketched the graph of my function, let's denote the endpoints and calculate the value of the function at those endpoints. So I'll denote the left endpoint over here, which is my t equals minus 3, and my right endpoint in this case is t equals 5. So now let's calculate the value of my function at those endpoints. Since my function is mod t minus 1, for the left endpoint, since my t is equal to minus 3 in this case, the value of the function over here would be absolute value of minus 3 minus 1, which is my absolute value of minus 4, which is 4. So this is 4. And if I again do the same process for my right endpoint, t equals 5, I'll also notice that the value of the function at t equals 5 is again 4, because mod of 5 minus 1 is mod 4, which is 4. So now I have to calculate the area under the curve for this function, which will be clearly denoted by the area of these two regions, right? Because it's area under the curve which lies above the x-axis. So this is the area under the curve of the left portion, This is the area under the curve for the right portion of my mod function or the absolute function. So if I am able to calculate the total area bounded by these two regions, denoted by region 1 and region 2, I'll basically solve the answer. And since in this question we wanted to calculate the signed area, we also have to take into consideration that the area below the x-axis is considered negative and the area above the x-axis is considered positive. And you'll clearly see in this case that I don't have any area which lie below my x-axis. So whatever area I'll get for my region 1 and region 2 will be considered positive. And this leads to an important observation that whenever you have to calculate the definite integral of a mod function or an absolute function, or if I have to frame it in another way, whenever you have to calculate the area under the curve, the signed area under the curve for an absolute value function, and you'll always notice this thing that no part of your area under the curve would lie below the x-axis because the absolute value function always gives you positive values, so you'll have no area or region which would lie below the x-axis. So this was the important observation that I wanted to share in this video, and that is why I took this example as well, so that we can realize this important fact about absolute value functions. And now the only thing left is to calculate the area under the curve, which can easily be calculated because I have two right angle triangles. So I can use half times base into height for both of those area calculations, and I can take the sum of both the areas because both areas are positive as they are lying above the x-axis. And then if I'll take the sum of area 1 and area 2, I'll get the final answer. So let's calculate that. But before calculating that, we also need this point in order to calculate the bases of both of those triangles, right? So this is the point where my function value approaches 0, right? So I want 0 to be equal to mod of x minus 1. And I can see that when my x is equal to 1, this holds true. So I know that this point, since this is my t-axis now, this point is t equals 1 in this case. And now since it's clearly visible that the height of both of our triangles is 4, and the base of my left triangle is 4, and the base of my right triangle is 4 as well. So now let's calculate the total area. So I'll calculate the area 1. The area 1 in this case is half times base into height, which is half times 4 into 4. And the area 2 is again the same. Area 2 is half times base into height, base is 4 and height is 4 as well. So if I'll take the total area, which will be my final answer denoted by A, my final answer is A1 plus A2, 16 by 2 plus 16 by 2, which is indeed 16. So this is my final answer, and this is the value of the definite integral of absolute value of t minus 1 when t approaches from minus 3 to 5. So that was it for this video. We learned two important things in this video. One was an easy approach to sketch the graph of absolute value functions, and the second observation was whenever we have to calculate the area under the curve or the definite integral of an absolute value function, we will have no area or region that would lie below the x-axis. In other terms, whenever you have to calculate the area under the curve for an absolute value function, all the areas or all the regions you'll have on the graph will be above the x-axis. So let's wrap up this video right now. I hope you found this video interesting, and I also hope that you found an easier way to sketch the graph of absolute value functions. Follow the channel in order to get notified about the other videos that I'll be uploading. Thank you so much for watching. Stay tuned. Bye bye.